Hello and welcome to my explanation of the experiment hardness of water. In this video I'm going to talk about the experiment and the calculations and just hardness of water in general. So we set up this experiment, and the aim of the experiment was to figure out and calculate the amount of calcium and magnesium in tap water as well as in boiled water. We wanted to figure out the hardness, the temporary hardness and the permanent hardness of the water. So we set up this experiment. Here is the complete setup with this beaker with tap water, 10 milliliters of tap water, and some buffer. Buffer has a pH value at 10. We use that to make the water have the perfect pH value to react. We also heated up both the boiled water and the tap water to make the temperature alike, so it wouldn't depend on the temperature. The reaction wouldn't depend on the temperatures. We then filled up a burette with EDTA. We zeroed it, and then we put some indicator, a bit of Ericom T black indicator, into both the boiled water and the tap water to indicate if the calcium and magnesium ions was completely reacted. The Ericom T black is pink or purple when there is still calcium ions in the water, and it's blue when all the calcium ions has reacted. So we did the same setup with the boiled water as with the tap water. Here you can see the pictures of the finished reaction where the water is completely blue, and also here with the boiled water. And then we have to figure out the amount of EDTA we used. The amount of EDTA in tap water, we used 27.4 milliliters, which is the same as 0.0000274 liters. We then had to find out the amount of EDTA, which is C times the volume, which is in this case 0.010 m times 0.0274 liters, which give us that the amount of EDTA is 0.000274 moles. We do the exact same with the EDTA in the boiled water. We can see that the number is a bit lower. It is 0.000185 moles, and that is because there is less calcium ions in the boiled water than in the tap water. Down here you can see the reaction schemes, both with calcium and magnesium. The calcium 2+ ions reacts with the EDTA 4- ions, and we then have calcium EDTA 2-, and the same with magnesium. Magnesium 2+ ions reacts with the EDTA 4- ions, and we then get magnesium EDTA 2-. So here we have the calculations. In the tap water, we will want to find out the water hardness. We do that by first finding the amount of the CaO in the water. The amount of CaO in the water is the same as the amount of Ca2+ ions, which is the same as the amount of EDTA. And the amount of EDTA 4- ions is the same as the amount of Ca2+ ions plus magnesium 2+ ions. So the amount of CaO is 0.000274 moles. We have the reaction scheme of the calcium reacting with the EDTA here, and we can then find the molar mass of the CaO. We do that by first finding the molar mass of the calcium and then the oxygen, and then we have the number here, which is 56.077 grams per moles. The molar mass of the CaO, we can find these numbers by looking at the periodic table. So then we have to find the mass of the CaO. We do that by multiplying the amount with the molar mass. So the amount was 0.000274 moles times the molar mass of the CaO, 56.077 grams per moles, and we then find out that we have 0.0154 grams of CaO in 50 milliliters of water, of tap water. So we then have to find out how much CaO we have in 1 liter of tap water. So take 1,000 milliliters, which is the same as 1 liter, dividing it by 50 milliliters, and then multiply it by 15.4 milligrams, which is the same as 0.0154 grams. We then find out that we have 307.3 milligrams calcium oxygen CaO in 1 liter. We can now calculate the water hardness of the tap water. So we take the amount of CaO in 1 liter, divided by 10 milligrams CaO per liter per degrees hardness, because there's 10 milligrams of CaO in 1 liter for 1 degree hardness. So therefore we have 30.7 degrees hardness in 1 liter of tap water from our experiment. We do the same calculations of the boiled water, and we find out that the hardness of the water is 20.8 degrees hardness, which shows us that the boiled water is softer than the harder water, which was the tap water. So we can now find the temporary and the permanent hardness. The temporary hardness is the hardness that can be removed by boiling the water. So we take the tap water hardness, subtract the boiled hardness, and we then get 9.9 degrees hardness. So the temporary hardness is 9.9 degrees hardness. The permanent hardness is the boiled water hardness, which is 20.8 degrees hardness. We then search the web and see that the hardness of the tap water in Herzogenaurach is 17 degrees hardness, which shows us that something in our experiment must be wrong. I think that it's the EDTA that is wrong, maybe the mixture is wrong or something. But we can't completely figure it out, but something must be wrong. So why do we have large amounts of calcium ions in the water? So we get our drinking water from the underground. For example, when it rains, the water goes through the ground down here and makes a layer, and then we pump the water up and use it as drinking water or to shower with. And the water travels through the ground, and in the ground there is a lot of minerals like calcium and magnesium. And the water hardness then depends on the amount of minerals in the ground. For example, some soils have more minerals and some do not have a lot of minerals. So if I should explain 1 degree hardness, there is 10 milligrams of CaO per liter in 1 degree hardness. 10 milligrams per liter is the same as 0.01 gram per liter. We can then find out the amount of CaO in 1 liter, as we did earlier. It is 0.0001783 moles, and we then know that the ratio between calcium and oxygen is 1:1. Therefore, calcium 2 plus ions must be the same as the amount over the volume, which is 0.0001783 moles divided by 1 liter, because we have to explain it in 1 liter. And it must be 0.0001783 molar masses. We know that the ratio between calcium and magnesium is 1:1. Therefore, you could say calcium 2 plus ions plus magnesium 2 minus ions must be 0.0001783 molar masses, which is the same as 1.78 times 10 uplifted in -4 molar masses. So we have a lot of regional differences in Denmark. In some regions we have hard water, as in Copenhagen, or soft water, as in West Jutland. The amount of laundry detergent depends on how hard the water is. So, for example, in Copenhagen we have to use a lot of laundry detergents to clean our clothes, and in West Jutland we need to use less laundry detergent to clean our clothes. In laundry detergent we often have EDTA, which react with the calcium and the magnesium in the water. Thank you for watching. See you later.